So thanks, Sinead, and all at the club for inviting me to this talk. It's a great pleasure, and I hope that we can proceed for the next 40 minutes or so with any technical hitches. And as Sinead mentions, we can have a chat afterwards, and if you have any questions, uh, no problem at all, I'll try and answer them. It's a pity that I'm not giving this talk back on Market Street in Clifton, where I was reared, and in the library, of which I have been a proud member since 1978. But we will get back there again, Lacuna J. Before I move on with the talk, I ought to explain to you who I am because I don't know many of you. I see your names here, but I don't know many of you. I know Sinead. My name is Phelan. I'm a native of Clifton. I was a great friend of Sinead's late brother, Garage. I went to the local community school. After my leaving cert 30 years ago, Tempest Fugit, I read physics and mathematics in Maynooth University, what was then St. Patrick's College. I went back some years later in the late 90s as a postgrad and worked in computational physics. And part of that work was the study of self-organized critical systems and its predictive ability with regards to seismological events. I was briefly a researcher with Ericsson in Internet Protocol telephony, an early predecessor of Skype. And I then sabbaticaled from science for a while, working in archaeological and historical research through the late 1990s. I spent 15 years in the Army as an officer in its Ordnance Corps. And would you believe it, I resigned my commission 4 years ago today. My military service was that of a soldier scientist, if you like, working in the areas of explosive chemistry, detonation physics, weapons specification and inspection, optoelectronics, air defense, explosive ordnance disposal, and counterterrorism. My career saw me travel the world from the Balkans to East, West Africa, Sub-Saharan Africa, the Middle East, Holy Land. After I resigned my commission, I about turned and went off to Trinity College to study philosophy, and I received a master's there last year, and I'm currently working in the civil service at the Department of Justice. I've had a lifelong interest, so professionally and personally, in physics and indeed astronomy, that I learnt at the knee of my older brother Peter, who has been a passionate stargazer since childhood in Clifton in the 1950s. So what are we going to look for or look at for this evening's talk? The talk will be sort of informal. It's a journey as such through the evolution and development of what would now be considered cosmology, from Ptolemy to Renaissance men such as Copernicus, Brahe, Digges, Kepler, and Shakespeare. And in considering this, we will discover connections, coincidences or not, maybe, between Hamlet, the famous play, and the progenitors of modern astronomy. The talk will draw down on some personal family research done by my brother and I, and a collation of real historical or indeed allegorical meanings between the plays of Shakespeare, specifically Hamlet, and the birth of modern physics. I also sincerely hope that some of you are somewhat familiar with the famous play Hamlet. It will make things a little easier to follow if you are. If you're not, it doesn't matter. I'll do a brief summary of the play at some point. Incidentally, if you want 3 books to read on this subject, look no further than our great novelist John Banville, whose Dr. Copernicus and Kepler you see here, and they're a complete marvel. These are my copies from 30 years ago, bought in the Clifton Library in September of 1989 during the Arts Festival, when the great man gave a reading. And I can still remember a passage from Dr. Copernicus that was on our Leaving Certificate prose cycle at the time. And in it, Banville describes Copernicus's intellectual breakthrough on heliocentrism when he makes the discovery, this feeling that he's had for a long time, that indeed the sun is at the center of things. And it's described by Banville as if, quote, the channels of Copernicus's mind had been sluiced with an icy drench of water. And I remember reading that at the time in 1989 and being very excited by it. Just the vivid, wonderful prose of Banville. And of course, Banville credits these 2 award-winning books to Arthur Koestler's The Sleepwalkers, which is an extraordinary book published in the 1950s, um, which is effectively a history of the scientific revolution. And it's an incredible book. Koestler was a famous writer, of course, a novelist, Darkness at Noon, political writer. But this book from 1958, I think, is superb. And I got it as a present for my 17th birthday from Peter, the brother. And this set me off on a sort of fascination for this period at the start, if you like, of the scientific revolution in the 16th century. Okay, so the play is the thing. And we will consider during the talk what the prevailing conceptions of the universe solar system were from antiquity up until the time of Shakespeare, the 16th century. And we look briefly at the models of Ptolemy and Copernicus. And during the talk, we will look at other models as well. It's important to do this in terms of how we set the scene, if you pardon the pun, for the rest of the evening. And I think most of you will recognize these two pivotal figures in astronomy, Claudius Ptolemy there on the left and Nicholas Copernicus on the right. Ptolemy was a Greek mathematician, astronomer, and geographer. Much of medieval astronomy and geography were built on his ideas. His world map, published as part of his treatise Geography in the 2nd century, was the first to use latitude and longitude, or ideas of latitude and longitude. And this idea of a global coordinate system was highly influential. And of course, we use similar systems today. He is probably most remembered, though, for his refinement of the cycles and epicycles that made the geocentric theory of the universe tenable for 1,400 years, as established in his famous book, The Almagest, on the motions of the stars and planets. This is the theory which Galileo and Newton later eventually overthrew in the 17th century. Copernicus on your right was a Renaissance era mathematician, astronomer, who formulated a model of the universe that placed the sun rather than the earth at the center. In all likelihood, independently of Aristarchus of Samos, classically, who had formulated such a model 1800 years earlier. The publication of Copernicus's model in his book De Revolutionibus Orbium Celestum, on the revolution of the celestial spheres, just before his death in 1543, is a major event in the history of science, triggering the beginning of the scientific revolution. He said in his book, I only looked at this recently, that he was somewhat reluctant to print it because he knew that he had conceived a radical notion and hesitated for fear of being, quote, hissed off the stage, unquote. Coincidentally, my current role in justice is government inspector of explosives. An explosion involves a sudden and violent burst of energy, but originally explosion was used to mean scornful rejection from its etymological root in the Latin explodere, which literally means to hiss off the stage. And there will be plenty more of esoteric historical details like this for the rest of the evening. Copernicus was born and died in Royal Prussia, a region that had been part of the Kingdom of Poland since the mid-15th century. He was a polyglot, he was a polymath, he obtained a doctorate in canon law, he was a mathematician, an astronomer, a physician, a classic scholar, a translator, a governor, a diplomat, and an economist. He was an extraordinary man. And this famous portrait still hangs in the town hall of his hometown of Toruń in Poland. So that's by way of background. From Copernicus, we move on to Tycho Brahe and Johannes Kepler, Shakespearean contemporaries, extraordinary individuals, ingenious, flamboyant, mad, profoundly influential in the development of modern physics. And it's been described that the relationship between these men was Amadeus meets the Da Vinci Code meets Hamlet. Brahe was a big aristocrat, well known, fond of the drink, fond of high living. Kepler was the opposite, superstitious, um, rather dark figure, but both extraordinary in their own way. Um, Tycho, the Great Dane, Tycho in Latin, won his renown as the last of the pre-telescopic astronomers, an identifier of new stars, including a supernova, and more about this anon. But after his royal patron dies, Tycho finds himself out of favour with the son and successor, Christian IV, and goes to Prague under a new patron, Rudolf II, the Holy Roman Emperor. As he prepares to publish his decades of celestial observations, all by eye, of course, Tycho hopes to prove that all the planets except Earth revolve around the Sun, which in turn revolves around the Earth. To help with his calculations, he brings in Kepler, a 28-year-old with his own weird model of the universe. Kepler was a devout Lutheran, as well as a Copernican, and believed that God created cosmic harmony by arranging the planets' orbits around the Sun so that they're spaced at distances corresponding to certain geometrical figures, which were the 5 Platonic solids. And Tycho introduced Kepler to the emperor and lobbied for his appointment as the imperial mathematician. But before Kepler's appointment was formalized, Tycho suddenly became ill at a banquet and died 2 weeks later at the age of 54. These are extraordinary figures. Tycho had a pet elk. He lost his nose in a duel. He had a silver nose for half of his life. And he was a well-known figure in Denmark, in Germany, across the Holy Roman Emperor in what would now be the Czech Republic. So it's important to mention these people, extraordinary figures in science. But let's return to the solar system models as mentioned previously. And from there, we will move on to more specific connections between the developers of astronomy at this time and Shakespeare's famous play. So we have here on the slide Ptolemaic and Copernican models of the universe. Ptolemy perfected a model of the universe in the 2nd century AD that remained the standard model up until the 16th century. And in this model, the Earth was stationary at the center and everything else revolved around it. And according to the Ptolemaic model, the Earth is the center of the universe. The planets, moon, sun, and stars are revolving around the Earth, and some of the orbits themselves have epicycles. The Ptolemaic model is also called the Earth-centered or geocentric model. In 1543, along comes Copernicus, and he publishes a revolutionary model literally, which is essentially the one that's still in use today, in which the Earth rotates on its axis daily and is merely one of several planets that revolve about the Sun. Though the Copernican model had been published before Shakespeare was born, it wasn't yet in fashion or in vogue in Shakespeare's lifetime. So what you were looking at here are essentially geo and heliocentric models of the universe by way of introduction. As an aside, this will be the only one. Ptolemy was also interestingly a cartographer, and he was hired and employed by the Roman Navy and produced Ireland's first map, which you can see here. It's worthy of another talk, I think, the history of this map and contrasting comparative identifications of the place names and geographical locations from Ptolemy's time 2,000 years ago to today. We go back to the solar system, and this time we look at Tycho Brahe's model. This is conceptually a geocentric model. The Earth is at the center of the universe. The Sun and Moon and the stars revolve around the Earth, and the other 5 planets revolve around the Sun. Brahe tries to combine the best of both worlds, whereby the Sun, Moon, and sphere of stars orbit the Earth, while the 5 known planets, Mercury, Venus, Mars, Jupiter, and Saturn, orbit the Sun. The King of Denmark was so impressed with Tycho's work on the new star of 1572, and more about that later, that he ceded to him a small island from which he could pursue his study of the sky. This island, Wien, is located in the sound between Denmark and Sweden, north-northwest, and a short distance away from Wien, lies the town of Helsingor, from which Elsinore Castle in Hamlet takes its name. Tycho built a famous observatory on a ravine from which he made visual observations. And he argued that if the Earth revolved about the Sun, as Copernicus proclaimed, then stars should appear to change their positions in the sky to show, as we all know, what is the phenomenon known as parallax. His measurements showed, however, that they didn't show parallax. So he concluded that they must be very distant indeed. And without attempting to calibrate his measuring instrument, which of course was his eye, and by quantifying the effects of glare, visual acuity, the atmosphere, etc., he leaped to the conclusion that the apparent angular size of the stars in the sky was in fact their real angular size. So this meant that they would have had to have been enormous and far greater in size than the Sun, which he thought himself was a complete absurdity. Moreover, he thought that the Earth too was too large and too ponderous to move. So he set it at rest at the center of motion of the planets and at the center of a thin shell of stars. But he did take seriously the fact that Mercury and Venus are always within 45 angular degrees from the Sun, and therefore, in his view, were likely to orbit the Sun. So he placed these planets along with Mars, Jupiter, and Saturn in orbit about the Sun, while the Sun itself and the Moon orbited the Earth. He placed the sphere of stars not far from the most extreme position of the Sun, as you can see in the slide, and he considered this model to be a great achievement because it was the smallest of all contemporary models at the time, and therefore conformed to another common belief that empty space served no purpose. He published this model in a book in 1588, which he disseminated far and wide, and most importantly for the purposes of this talk, it was disseminated far and wide in London, in England. There is another model. Thomas Digges, 1546 to 1545, and he's often considered the first Copernican in England, which is to say that he was the first to accept and defend the proposal that the Sun is the center of the solar system and that the Earth is a planet that orbits the Sun. Both the Ptolemaic and Copernican systems were contained in a crystalline sphere beyond which lay paradise and the realm of God, the prime mover. By contrast, in 1576, when Shakespeare would have been 12 years old, Digges extended the Copernican model by suggesting that the stars were like the Sun and were distributed through infinite space. He was therefore the first Renaissance scholar to publish the idea of an infinite universe. The stars did not rest on crystal spheres, but extended into infinity space. A profound philosophical leap at the time. In 1576, in a popular almanac with the wonderful and extraordinary name Prognostications Everlasting, published by his father Leonard Digges, Thomas made a bold leap by embedding Copernicus's sun-centered planetary system in an infinite system of stars. And his memorable essay is entitled, and you can see it there, A Perfect Description of the Planetary Orbs. And interestingly, it was written in English rather than in Latin. It was written in the vernacular. And of course, Latin was the scholarly language for another 200 years. So consequently, by virtue of its English writing, it gained wide distribution among the public. And the essay included a summary of the first chapter of Copernicus's famous treatise, Orbium Celestium. He went further, though, and proclaimed that the Sun was situated in boundless space filled with stars. This Diggesian model, as it's sometimes known, was a stark contrast to the old geocentric model of Earth-centered planetary orbits encased in a shell of stars. The new model required thinking beyond appearances, and this upset many people, in particular theologians, who had been concerned that Copernicus had sidelined humanity, who were supposed to be the prime concern of the Almighty. And they continued to question and oppose this new paradigm.